Hi everyone, my name is Malik and today I'm going to do a project demo for our project 2 of CS6320. In this project what we're going to demonstrate is how to deploy a scalable Node.js web app using ECS with Docker. So the goal of this project is to show you how one can leverage the ECS CLI to deploy any web app based on Docker containers straight on Amazon ECS and how to scale them. So let's get over the review of what exactly is ECS. So we start with the ECS, and basically ECS is like a service offered by Amazon which is highly scalable, fast and container management service that makes it really easy to run, stop and manage Docker containers on a cluster of EC2 instances. So what this does is it helps us provide a layer of services that we can start over instances, and those instances are pre-configured with Docker installing them, and it runs the containers on them. So the main parts of an ECS service are, first one is the task definition. So um, with ECS you first define your task, how you're going to run your services. Let's say you have an app that runs MySQL and Word, it uses Node.js. So you have two services and you will define how you're going to run them, what ports they're going to use. Later it schedules them on a set of EC2 instances. So those instances are defined by the user. There could be one instance, there can be many instances. And later it starts the containers, the actual Docker containers, which are the services that are going to be started after them. There are many benefits of ECS. ECS is very elastic web scale computing. You can scale it to many containers, which means that you can scale it to many instances of the same app. It is completely controlled and there is no additional charges for that. It supports Docker Compose style YAML files. So a Docker Compose style YAML file is the official Docker uh, standard of declaring your services in the form of YAML file, and you declare your services and you declare the attributes, like what are the service name, how, what ports is going to access, and what are the different processes that are going to run in the container. So the features of ECS are the containers and images, which supports out of the box because it's using the same Docker container technology. And then this the task definition, which are the actually YAML file configurations. Then you have cluster, where you can have one or more EC2 instances with Docker containers running on them, and this whole set of instances is called cluster, and you manage that. Then you have task and scheduling. This is responsible for placing tasks on the actual container instances. So a task is simply an instantiated running form of task definition. When you run a task, you actually have services running, and then you have container agent, which is responsible for bringing up new containers on an EC2 instance. So we'll go over and demonstrate how our application is working. So I will first go over and say the first step is actually to install the ECS CLI. This is the Amazon ECS command line tool that you have to use in order to manage your ECS cluster. So installing them is pretty straightforward. You just copy the binary from the Amazon link, and after that you configure your ECS with the credentials. Once you're done with that, the first step is to actually create your own cluster. So I'm going to create my first cluster here. And as I said, a cluster is a set of instances actually. There's nothing running on them. You just define how many instances are you going to run. So here my cluster is using the key pair ECS. This is the actual Amazon key pair from EC2 console management. And I'm going to say I just need one instance because my app is really simple right now. And the instance type is due to the medium. So I will start and create my new cluster here. So the cluster has been started. It's actually creating the instance, is configuring that, and it's making sure Docker is installed in that. This will take some time. The cluster creation is a process of actually creating the instances of your cluster, and those instances will have all the Docker containers run on them. So uh, a cluster is just a logical set of EC2 instances. That's it. A cluster could be one instance, a cluster could be many instances. So it's all up to your application, and it's up to users demands and needs, what their preferences are when they're deploying a app on ECS. So our cluster progress has been started, and also you can use the ECS CLI to view the cluster. So I use ECS CLI because that's the official documentation of how to use ECS. But you can also, yeah, you can see this, how you can create cluster here. This cluster name, you can create an empty cluster with no instances on it. So right now I have a couple of clusters. One of that is just getting started right now. Yeah, the creation is in progress. So once my cluster is up and running, that means that my instances are already there. So of course next step will be I will have to provide my task definition file, which is going to be a YAML file, and that YAML file is in the format of Docker Compose YAML file. So Docker Compose YAML file is the official Docker way of declaring your services. So here I have all the services listed here that I want to be run in the form of Docker container. Each of these services will run in a separate container. So you see MongoDB is going to run in a separate container named Mongo, and it's going to use my image, Docker image. So Docker image is like a static file, static definition. It's like stored. It's like a um, image file. It's got everything installed in there, but a running image is a container. So a container is nothing but when if you have an image running, you call it a container. So once you run an image and you have some process running, you just call it a container. So every container starts from an image. So that's the definition of it. So I mean, take of image as like an ISO file or like a disk file, but if you have a running operating system, you call it a container. So the analogy is kind of like the same here. So my first service is MongoDB, which is the database for my app. Next is the HA proxy, which is very important, and this is where we are going to demonstrate how our scalable apps can be deployed. So HA proxy is a load balancer. It's going to load balance between 4 apps. All these 4 apps are Node.js based apps. So all of them are using the same Docker image because they are just single app, but they are multiple instances of the same app. So since we are deploying a scalable, highly available system, we need to have multiple instances of the app with same image, but they are going to be linked to HA proxy. So with this, what the idea is like HA proxy is the load balancer, and it's going to balance between all of these apps. So even if my app 1 goes down, I will have app three apps running, and HA proxy will make sure to automatically redirect the client request to the running instances. So this will get a highly available system. So my cluster is still getting created, and once it's done, we can go ahead and move to the next tab, which is really simple to start one new compose file. So with this, as I mentioned, you need to provide the Docker images. Those Docker images exist in a centralized place called hub.docker.com, and hub.docker.com is like where all the images exist. So these are the images under my account, and these images are built and pushed by me, and I define them how these images should be run. So app and HA proxy, I define them, and it, it just gives you more freedom. Like you may want your MongoDB to run in a different way. Some people may want to have their MongoDB have a different set of packages installed in them. So it gives you more freedom. Docker hub.docker.com, you just need to have your account and you start pushing your images over there. So images are just uh, immutable form of containers. They are not running, they are just like actual storage file. Yeah, my cluster is created. Cool. So I'm going to go ahead and show you what EC2 instance they're running on. Yeah, so my EC2 instance, there you can see it. This is the one that's running on. This is the private IP. So this private IP is where all my apps will be bound to. So each app that gets started, right, it starts on a specific IP address. So HA proxy needs to know this IP address. So I'm going to create an image for HA proxy here to use this IP address so it can route in a correct way. So I'm going to bake this information in the HA proxy image. I'm going to save it, and then I will say this. So since this is a different version of HA proxy, I'll just say this is .5, and I will say docker compose build Malik proxy. So it's going to build my new image with the new IP address baked in that. And now I'm going to push that image. So I'm preparing to push this image to the hub.docker.com because we need to push our image so that ECS can pull it and start our new container. If the image is not there, it's going to complain and our app will not get started. Everything is set up. Now it's time to start our actual services. There we have our containers getting started. Where you can see container ID is given, app for status is pending and starting them ECS. See, we don't have to SSH to instance, but we'll make sure Docker ECS takes care of that. So I'm on my laptop on my host machine and I'm just sending the request and making sure it's there. Once it's done, I will just run this command to see what the status of the container is. Yeah, so let's go back to a brief overview. Where what we are going to do here is like we are deploying different, yeah, what we are building here are like, this is our traffic, which is the client. It hits the HA proxy, and HA proxy redirects to each Node.js app, and each app container has also HA proxy running. So HA proxy is using round robin algorithm to rotate between each app. So this gives us more scalability and highly available way of deploying application. In the bottom, in the underlying layer, they are both using MongoDB and Redis. So this is what we are actually trying to achieve here. Right, all the containers are up. So let's see what's the status. Cool, all my containers are running now, and I can actually go ahead and see what the status is. So this is the time we verify our app is running. So as I said, my apps are running, but I don't know where they are running. So see, so load balancer is first sending the request to app 1, which, and the port of that app is 8081 because the app itself just prints out what port is running on. I make one more request. Now this is round robin, so each app has two processes are running. Second time is the same port. Now it moves to the second app 2. See, I have 4 apps running, and back to 1. So this actually demonstrates that our app is scalable. We have 4 instances of the same app, each is running on different port, but HA proxy makes sure that it can rotate between each app. So if one of them goes down, it can actually switch to other 3. So this is how you can deploy scalable apps using ECS. It's really simple, and all you need to do is like declare everything in a compose file. Make sure your images are there in whatever registry you are pushing to, public registry or EC, a different registry. Declare what kind of port they are going to run, and with this you can actually deploy anything. It could be Cassandra, it could be MySQL, it could be any application, a Java application. It doesn't matter. You just define your services. You tell your ECS client, hey, use this compose file, and it automatically starts the container for you. And it's super helpful for deploying applications from your machine or remotely, and you don't have to worry about ECS to instances anymore. As you see, I didn't have to SSH to this instance a single time. Everything was done, deployment was done automatically. So ECS is a really cool tool if you want to deploy dynamic applications very fast, in a quick way, and in a scalable. So a very plus point of ECS is the scalability. So go through all of these. We verify that everything is running. You can actually verify that from the console too. This is our cluster task. See, all my apps are running. So HA proxy, it gives you everything like what ports is connected to. This is the actual port is connected to. This is where external link is. My app 1 is running on 81, it's bound to 81. Similarly, app 4 should be bound to 84. Yeah, so 4 apps, 4 different ports, and HA proxy equally load balancing between them. So this is our short tutorial. I hope you found really helpful about ECS and how you can use ECS with Docker to deploy any app and scale that. So thank you so much.